Hey all, I'm pretty excited about this, so let's keep going. We got 2 pages left, so not too bad. The first one is, and by the way, this helps in the homework, huge. There's an example almost like this, but on different numbers and variable placement. It says find the values of the variables in the given kite. So this time we have a kite with only the long diagonal drawn. I need to find the different ones. But do you guys agree with me? In a kite, we talked about our theorem from the other page, is that we know that pair of opposite angles are congruent. So I can sit there and say, all right, 5x minus 15 is equal to 4x plus 13. Subtract the x. Add 15. So what do we get? 28 degrees. So that's how we solve for x. But now y gets a little bit trickier. I'm going to give you a hint for my y. Our theorem. The long diagonals will bisect angles. So what I'm going to do is actually this. I'm going to use the fact that these two angles are the same size. So that means this is really y minus 9 degrees. Okay? Then, if I know the measure of this angle, which I can get by plugging and chugging, I can add these three together. So I'm going to go over and go 5 times 28 minus 15. And what that gets is 125. 140 minus 15, 125. So then to solve for y, I'm going to go 125 plus y minus 9 plus y is equal to 180. So I get 2y plus 116 equals 180. I always combine like terms first before I start adding and subtracting from different sides. Subtract 116. Be 64. Divide by 2. Y is equal to 32. So that is pretty cool. Now, those hopefully will help you. I'm going to let you look at that for just a second. Let you get caught up, because I know I do my math pretty fast. But we also have actually two other figures to do, and they're trapezoids. One's just the generic trapezoid, and one's the more specific one, which gives us a lot of cool properties. So here's the first part. A trapezoid is a quadrilateral, and don't forget this is huge, that's the def. So I would make sure I know this one really well, okay? A trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. You want to know those. So those opposite sides actually have names. They're called the bases, okay? All right, so you have your base right here. It's this segment and this segment. Those are the base. The non-parallel sides are called the legs, kind of like an isosceles triangle and a right triangle. So those are the legs, okay? And then we also have what are called the base angles. The base angles of a trapezoid are two consecutive angles whose common side is a base. So A and D, angle A and angle D, are base angles. And we know that B and C are called base angles. Now, just a sidebar, remember notation way back from finding area? You'd have base 1 and base 2. Those help us solve for area later. But there's one other thing I want to emphasize, and I didn't really do a good job of this in class, and I'm really sorry. But know, if you're formed by the same leg, those two angles are going to be supplementary. And the reason why they're going to be supplementary is because of parallel lines. They end up being same side interior angles. So those two will always be supplementary, and those two will always be supplementary. They always help each other out. And then on the next one, I think this whole definition is huge, so I'm going to write it out. Make sure you emphasize it here. It says, if the legs of a trapezoid are congruent, then the trapezoid is called an isosceles trapezoid. Very similar to working with the triangle. And I want you to draw this out so you can see what it is. You have your two legs are the same size, and then we have our parallel sides. That's an isosceles trapezoid. So hopefully this is the one that has all the cool powers. This is where we get our theorems based off of it. So if we really don't have an isosceles trapezoid, we don't have a lot of exciting fun things to do. It's just that's the way it is. So if a quadrilateral is an isosceles trapezoid, and by the way, make sure you know these. Huge stuff you need to know. the first thing you know is that each pair of base angles are congruent. So that means these two are congruent and those two are congruent. And that only works if we have an isosceles triangle. So this is cool. These are still supplementary. These two are two supplementary. So don't forget that. But these pairs are going to be congruent to each other, and that's really huge. And the neat thing is this is really just the converse of the previous one, but it says the following. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. It's just saying, hey, if you know it's a trapezoid, this will always be true. And here's something for the future. Notice the right triangles I just drew in. We're going to use that huge when it comes with isosceles trapezoids. And then the last one, which I always think is important for everyone to know, say the top one and the bottom one here is the most important ones. It says a trapezoid is isosceles if and only if its diagonals are congruent. So these two right here and here are going to be exactly the same size and shape. But please understand, they do not bisect. They intersect but don't bisect. But here's something cool. Those two will be the same size and those two will end up being the same size just as a result of some congruent triangles and stuff. We're not going to go into more detail than that, but it works every single time. I just love it. So let's go ahead and let's work some problems on the other page.